She will not be blind, people, but the dark of a velvet night. She will watch the tables turn, stay out of sight, wait away out of sight.
Well, that's our next managed code review. Everybody, thank you for coming. You know, you gotta make sure you watch out for those red lights, especially when you're doing interop code. So, please don't be afraid. We do not bite, and we definitely can't bite all the way to the back of the room. So if you could come up, we would greatly appreciate it. My name is Searles. I am the Vice President of the Northwest C++ Users Group. And we are very involved in the community in the Seattle area and worked closely with John Cobb on helping you with this event with volunteers and planning and other things. So we appreciate that you guys are coming to this event and especially this session. I've worked in many different languages. I'm currently working in Java/C++ for the Android platform and also assembler. So that's even more interop. And I've also worked with WPF/C# code and managing that with either CLI or COM-based libraries. So I'd like to have the rest of the panel please introduce themselves.
My name is Gregory. I work and I'm the unfortunate owner of the .NET interop world. I've recently joined a team because of some needs there, but I've been doing managed interop for over a decade. So I do work at Microsoft. I am online in the GitHub for CourseLR very, very regularly. Before that, I worked at MathWorks and worked on the interop side there, helping people write Next files, Java, Fortran, Ada, basically whatever was needed to write a high-performance mathematical computation and bring it into MATLAB.
Cool. I'm Gregory. I like to say I've been using C++ since before Microsoft had a C++ compiler. But I pretty much switched once they did. And I took a detour in the early part of the century into C# for a long time. And so now I'm in this weird space where I know MFC and I know WPF. And you know what those things are kind of unusual. So I have to take this because
Okay, I'm Lloyd Moore. I work as a consultant. I'm also the president of the Northwest C++ Users Group, working at Brett. Primarily, I work in C++, and I'm in the embedded system space, primarily in Linux these days. And that gets you into a whole bunch of different realms. I've been in virtual reality. I'm currently in aerospace, industrial automation, and a lot of those areas you end up doing interop as well.
So if any of you have any questions, we have two microphones, one on each side, so we'd ask that you could come up. This panel is for you to ask questions. We aren't having any presentation, but we're here to help you.
Hello.
Hello.
Is it safe to say that there will be any new feature added to C++ CLI?
Okay.
I don't really know. Do you mean
The language?
Yeah, the language. I guess I'm not the best person to actually ask that, purely because there's a lot of business. That's a very loaded business question. And so I'm really not on the business side. I will say that C++ CLI, when it came out, Microsoft pushed it very heavily, and some very important people took a bet on it. Adobe is one of them. How much we continue to invest in that as far as adding new features, probably not, but it is something that will be around for the foreseeable future.
it serves the purpose that it needs to serve right now. So it's not like it's missing something that needs to be added to make it usable. So the pressure to add random things is probably nothing.
Do you need a feature that you would like to see in CLI?
I can think on top of my head that as one is being able to use Lambda in a function instead of having to create a functor to be able to submit a short piece of code. It seems like typically wise if you would use GC root and open mechanism, there would be a way. Now I always think I always tell people there would be a way, and I forgot about all the edge cases which would be hard to implement. So of course don't take my word for it, but I don't know, it seems like it could be possible. It's not a big deal of course, but it makes your natural style of writing code in C++ evolve to even 14 or 17. Or shit, I have to go back to writing a functor, and it's not very natural, I'd say.
Yeah, that's a great argument for it. That's not something that I can see we would want to invest in, at least from the developer side. Like I haven't heard anything about that. I can say that there is active investigation on bringing support for C++ CLI to the .NET Core world. I don't know if that's of interest to you, but we recognize that it is very useful. And there are cases where it has a lot of value, but I don't know about adding new features. That kind of feature seems like does have value, and if you could find a larger group of people who are interested in that, that's something that Microsoft would take very seriously. There has been a very strong shift to what does the user community want? User voice is a great place to put up a suggestion, and I can tell you without question, we get reviews every 2 weeks. What's the number one thing on user voice? That's what we better be working on. So that there's a very big push at Microsoft for that. So if it's important to you, do it.
And I'd also say that CLI is an interface to be an interface between C# or managed code and your C++ unmanaged code. So I don't see how they would, or the impetus to put that in has to be from the user's push, because it's just an interface. It's just, I'm using this so I don't have to worry about a problem with interfacing between the two.
Okay, thank you. I think there's one possibly asking a question. I would like to, would you mind going a bit further what you just said about bringing the CLI to .NET Core? Explicitly, what does it mean? I know you cannot make any promises, but what is the thought there?
The thought there is that at present, when you compile, and this would only be for Windows, just to be clear, nobody's considering writing a port to GCC or client. That's another set of complexity that we don't want to necessarily get into. But just adding the support for writing a C++ CLI application that could, instead of use .NET Framework, use .NET Core. And those design documents and those issues are 100% public. They are on GitHub for CLI.
Okay, thank you. I'll come back later for a question.
Okay, next.
So we have a code base which is C++ and C#, and we use C++ CLI to pull into C#, but the C# targets .NET Framework 3.5, and as far as we can tell, that means we need to use the Visual Studio 2008 compiler to compile the C++ CLI. So is there a better way? Can we use a more recent version of the compiler to compile it and still target .NET 3.5? Or is there some other interop solution other than C++ CLI that would be better for just straight pulling into C#?
That's good.
So first of all, why do you want 3.5?
Because some of our customers are on Windows 7 and only have 3.5.
Well, I know that Visual Studio 17 will allow you to change which target for compiling. So maybe you could run a higher, for the C#, you could probably run the code at a higher .NET level and then interact with.
Right, yeah, the C# code compiles targeting 3.5 just fine with Visual Studio 2017. It's only the C++ CLI code that we need the older compiler for.
for what it's worth, I'm working on a project now where 2017 and 305 will have a problem. I don't even remember what I had to do, if I had to do anything, but it's working. So I'm not sure exactly how we can discuss it later, but it's working fine.
Yeah, there should be I don't know if any obvious limitation on using a version of Visual Studio to target an older framework with C++ CLI. I would be very interested in understanding if there was, so feel free to hear me after. As far as what are the options, a very common, four-letter word is COM, and there is the COM interop story, and you don't necessarily have to do a full registration and all that. But doing COM interop is a more, I think, nice object-oriented way of getting objects so you can work with them by defining interfaces and making interop assemblies and passing these contracts between exactly helps you, but that is another way of doing it.
Yeah, that helps. Thank you.
So my question actually relates to your latest comment, your very last comment. So when calling from native to managed, indeed it might make more sense to actually explore that as COM. But do you see any, can I phrase that correctly? Do you see any value in exposing native code through COM just because you want to interact with managed code instead of using C++ CLI?
I think it depends the direction you want to go. So if you want to call the native code from the managed code, it just works. What's the official name?
I do believe
Okay,
it's just first.
That's just the easiest thing to do. I wouldn't bring COM into the picture.
Neither would I.
But if you're going the other direction, call it from the native to the managed, then it's more of your option.
Thank you.
Mr. Reynolds, next.
Thank you. So we are using, I think, always the same goal to interact from native to managed in some way. So in our case, we have both-way interaction. Our native to call managed because managed knows how to do things simpler or something more complicated that is already done and tested. And then we have like a way to go back and do things in native. So our C++ side of the things, it's like older, traditional, original code implementation. I'm wondering if you can simplify or improve or bring better tools. So basically, would all the same mechanisms work if you just have upgrade to VNRT home implementation? Is there a benefit in doing so?
The async is a great argument. I guess you're really butting up against a business question. I think the official Microsoft statement would be, yes, you should move to WinRT API service. I don't necessarily think that's always true. I think, as Kate mentioned, async is a great reason to use WinRT. Those interfaces that they provide for you. I can't think of anything other than that off the top of my head that would have a huge value add for WinRT.
So it sounds like if things just work for us, we can just keep it as is, no additional benefit in other. And because it sounds like async would require some special, maybe re-architecturing of our communications.
Well, it's more a matter of like if you have an application right now that blocks while it's processing a file or something, and you just used to live with that because the files used to be X big, but now they're 10 or 100 X big, you're going to have to do something about it. As part of that, maybe you could embrace because the services that you get through WinRT are async services, so you sort of change your life. But if you're not feeling that, then learning how to do things a different way probably doesn't make sense.
Okay.
Hi. For some background, I work on a framework that exposes some C++ interfaces, and then our customers implement them. And one of the things we also do is we allow them to write it in .NET languages like C# or whatever. And do that with a bridge component that's written in C++ CLI. And recently, we had some issues with customers reporting problems like, what if we run this in different app domains in the same process? So this is like a native library. And I was searching online about this, and there wasn't much guidance or anything about what people expect in this kind of situation. So native library, native entry points, but the implementation uses .NET. But then it's used from a .NET application. This is ODBC, for example. Like, what are your thoughts on that?
Native libraries are loaded once, and they are in all app domains. So that the native library, so like if you key invoking something in .NET, that native DLL is visible in all app domains. So there's no app domain consideration there. As far as if the implementation is in managed, you're bound by the app domain rules. I guess I don't fully understand the problem that you're having.
So we have some like globals that are managed objects, but they're like via C++ CLI. So it happens if two app domains use this library, one of them will be not on the same one that the native library was loaded in, and so the objects are on the other app domain and the problems occur. I was wondering what's the easiest way of avoiding this issue? Is there any sort of kind of guidelines for writing this kind of library?
Got it. So just let me try and distill that. You're saying that you have statics that are present in one app domain, and then in another app domain, they're trying to access those statics.
Yeah, because it's just native code using a global object, and it happens that the implementation is kind of managed, but the native code doesn't know about this. It doesn't know anything about app domain.
The static cross-app domain communication is probably one of the most complicated and least understood concepts in .NET, and you can get yourself into very, 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 very bad situations. I can't remember the exact details as far as static, and that's funny because yesterday we were just having a conversation about this, but if I recall, statics are app domain dependent. So potentially you could have statics in one app domain and another instance in the other app domain.
Yeah, I think you could mark them as an app domain local or something, or as a keyword.
Okay, and
So then you think the right to share one, but you're just running to your own private.
yes, that is entirely possible.
So you probably need to check if the domain exists in the other application, and if it doesn't, re-instantiate it.
So my thought after looking at this was probably the safest thing would be to run managed code inside its own little app domain, inside the native library, so it's isolated from everything else. But there doesn't really seem to be an easy way of doing that without changing a lot of code.
Yes, when you start dealing with CLI, and this is kind of one of the criticisms, as Greg alluded to, it's kind of like this very thin interface concept. When you start building tons of applications that have very large dependencies on it, the app domain rules, assembly loading rules, probing paths, security involved in how you load app domains and configure them, quickly becomes, I didn't realize I was doing that, and now I'm in a very bad situation. I don't know how to get out of it. I would have to look at exactly what's going on there and see what the problems are. I will say that what you are hitting is a problem, and it is a very well-known problem. And the solution is, unfortunately, don't get into that problem. And I would actually just have to look at what is going on, understand, and give kind of like a, what could you do to make things better there? The area is so dense and esoteric that it really would require a tailored, I need to look at what you're doing.
Yeah, this isn't a Googleable problem.
That's what I found, yeah. So yeah, my best idea so far is basically scrap C++ CLI, wrap everything in COM, and then do it that way. But that's a lot of work. So I was wondering if you ever do this.
So what's your, I mean, are you running on two different computers, running a server slash local machine?
It's just it's like an ODC driver, usually.
Okay.
Yeah, so it's a shared library. And then when people use it from .NET, when they look into it, you see it loads just as an A library, but then they kind of multiple applications, they have the same process.
Oh, I see, so you're creating your SQL connection and it's only instantiated once. Okay. So you probably should check your SQL connection if it's a lot open or closed in the native layer, and if it isn't, reload that layer.
Now, I would also say, like, do you have to have those globals? Is that the only way this can happen? Is it maybe less work to rejig your interfaces so that everyone gets given what they need? And then you are still in different applications, but it doesn't hurt you.
Yeah, unfortunately, not really a huge lot at this point, but yeah. If we start from scratch.
Yeah, well, if you all go back 20 years, my goodness, things will be different.
Spain.
Yep, and it says 2020. Well, you go ahead.
It could be a loaded question, and maybe it's public, but I haven't read it. Why did pure and safe no longer mark as obsolete?
Pure CLI, so when you compile the C++ code with C++ CLI, you used to say /pure and /safe, and you got different variants of C++ CLI, and now it's just /CLI. And it was a live question.
I think, I don't really have a good answer for you. I do know that they have been marked deprecated. I think the contracts that you get with them aren't what people were expecting.
Yes.
And that's basically, we really don't know how to message this, so we're going to remove it.
I think the rude way is like /safe wasn't safe and /pure wasn't pure, but that's unfair. It was that it didn't mean what you think it was.
Thank you.
That's really
Well,
awesome.
unsafe, especially in .NET, meant that you could use pointers. And so that was unsafe because you weren't able to delete it correctly.
No, what we hate referring to is the C++, the CL.exe flag to enable C++ CLI. There was a modifier verb for the flag that said, is it pure, is it safe? I thought there was another one.
Yes.
Yeah, there was another one, and they had very subtle and not obvious meanings, and your mileage may vary depending on what you're compiling, and like a lot of flags on compilers, if you set them, you got a very different outcome, and you may not necessarily understand why, and so it was, you don't see a lot of use of this, and people aren't having a lot of success, we're going to remove it. I wish I could give you a better technical answer, but I don't really know.
Hey, it's me again. So in our line of work, we have to deal a lot with Windows Server configurations. Luckily enough, recent versions such that they are fully configurable through PowerShell. Because at some point it became standard in Microsoft that everything that you release should be configurable through PowerShell. Now what's unfortunate is that it's very easy to call any PowerShell from .NET. You have run space class, you can pass arbitrary commands, you get kind of objectified PowerShell objects as a result of it. What's unfortunate is that there is no way just to do it from C++, unless you guys know, and you'll give it to me now. What we currently do is something very ugly, just construct commands, call them directly through PowerShell executable, and then do some crazy parsing of the results.
VB script, that's the answer.
I don't, PowerShell is entirely managed. And I don't, and it's, as you pointed out, it's serialized. It's, that two-string overloaded concept shows you this very prettified results. I'm going to say this, and I don't want anybody to come after me, but one option you may have would be WMI, but I don't know I don't know specifically what you would be looking at. From at least, and this is on the .NET side, I'm not on the Windows side, and we don't always communicate with how we're doing things. We kind of just, .NET just provides a platform. The rest of Microsoft does what they want with it. And so the idea is that PowerShell is the canonical way of configuring servers, because doing things through WMI, I think WMIC is the classic way of doing configuration, is just so terrible. And PowerShell scripts are a little less terrible, a little easier to debug. And so that's just kind of the direction that people have gone. I will say, like the CLI enhancements, user voice is a really important thing. And if that's something that you absolutely need, you need a native interface for PowerShell to be able to call these objects, that will be considered. If you get enough votes, let the community speak here.
Yeah, it sounds like not too many people here today, otherwise I would ask everybody to do something like that. Just as you said, PowerShell became the de facto standard of doing those configurations. And not having an ability to do C++ seems like a gap to me. But let me ask a different question on the same area. What would it take to turn this PowerShell runspace class into a fully supported COM object, such that we can just construct it with some COM factory, get an interface, and just get going in C++ without CLI? And then all the complexity of management will be hidden by whoever implements, by the server, by the home server.
And you could, I think this is a place where you could use C++ CLI to make that interface. You could instantiate that instance of that object, provide some sort of COM generic abstraction on top of it, or go the other way. Create a library in Manage that takes that PowerShell object, or with that root, wraps it into a traditional COM interface, and it is consumed from native. The other little dirty secret that I don't necessarily really advocate, but most managed objects implement iDispatch. And you could, if you wanted to, register that PowerShell object properly and use iDispatch to drive it. There's a lot of danger there, but you can do it.
Yeah, he's already parsing when it's back. It's already dangerous things happen.
That's great.
That's a little bit more.
That's
correct.
Go for the guest.
That's fair, okay.
Any other questions?
Well, that's kind of more general question. There's no other questions. So I dabble a little bit in the IoT space, primarily as a C++ developer. And in IoT, there's all kinds of different images from like things like tacos. So everyone's kind of building their own custom images and deploying them to devices. And the tool chain helps with some of that, but it's custom scenarios, and sometimes we're waiting for the tool chain to catch up. And then there's other technologies like Docker, which kind of let me, as an application or a library developer, not even think about what the environment of the device is, and I just get to kind of deploy stuff on there. Is there anything in kind of this managed, unmanaged world where we kind of get to meet people in the middle, or any technologies being developed there? And kind of the second part to that is with machine learning and Python kind of emerging as the more dominant language there. Is there anything where we're not just interacting between kind of well-known interops like C++ and C#, but also C++ or embedded code with Python?
So let me pick that up a little bit. I want to find out a little bit more about what you're doing. Are you talking about interop within device or across devices first?
So purely on device. So
Purely on device.
Okay. I'm trying to raise up from the world of being embedded and be more of a cross-device library developer, but I want to hit as many people as I possibly can. Right? I want to be able to deploy to a Raspberry Pi or a Dragon board, or no matter what kind of images they're running. And I don't really want to have to think about, oh, I got to compile my code for all those things. And what are the ways do I have to compile? Do I have to find a cross compiler, or I have to deploy the device and find a tool chain, or I have to have some custom tool chain that's provided to me. I just want to write some C# or some Python and hit all those things.
And then, so let me ask one more question. You're mainly looking at the bigger processors, like the larger ARM processors, 32 bits, 64-bit like a Pi. Not something like a very small processor like a microchip or a MSP 420, for instance.
Yeah, something I would say is kind of like a mini computer, like something that's able to run sort of normal applications,
Yeah.
Android or Android.
Yeah, you got an OS under you. Okay.
Yeah, exactly. I have an OS image, maybe it's IoT4, maybe it's like a custom laptop image or something.
Sure. So I think you're on the right track with Python. Python is going to give you pretty good independence. One thing you'll run into that you need to be aware of, depending on the specific platform that you're running on, not all of Python may be deployed on every single one. Normally it is. I've run into some that have more restrictive sets. That set is not too bad. You usually just deploy pieces that are missing. The other way you could go, well, even if you go with Python, you're still going to need some form of cross-compiled C++ native code to interface down to the rest of the system for anything that Python doesn't give you. The other way I've seen people do this is with JavaScript. And that works to a fairly good degree as well. So it's kind of which language do you want? You run into the same problems. You still got to have something underneath to actually, make that connection from the Python or the higher level language world down to calling whatever you want on the actual platform. Sometimes that's done with interop. I've also seen it done with just building a set of executables. So do you know what you want to do down at the lower level?
Yeah, let's say I have a small set of functionality that I don't mind writing across twice. I want to try to maybe put 2 of my developers on it instead of a whole team of write everything cross-platform.
Yeah, exactly. So you could basically write that minimal subset and cross-compile it. And that could either be a set of executables or it could be a library of some form. And then basically use the Python or the JavaScript as a scripting language on top of that. Plus whatever you get out of that language. So you can open sockets and communicate and do HTTP requests or whatever from the top level. It's just if you're going after custom hardware or something at the bottom level, yeah, you're still going to have to compile that cross-platform.
And do you guys know if that's being used a lot in the industry? The performance of that interop layer keeping up with sort of requirements?
Depends on what you're doing. If you're doing very high performance stuff, no. And by very high performance, like I was doing some virtual reality type things. So I mean, real time.
So is this real time, or what's the focus of this?
This is a bit hypothetical. I'm afraid I can't get too far into specifics. It's very prototypical, but just I was curious about what's available in the space, and I hear a lot about. Okay, well, here's what you want to do if you're a C++ developer. Here's what you're going to do if you're an app developer. You're going to deploy a Docker container.
There's another option, and there's other constraints. And I am not an embedded developer. I have a little bit of experience just from hobby. But you have Mono, which is written in C, and that's really relatively compile it, do whatever you wish, and that will give you a .NET runtime. That has an interpreter mode. It's actually what Unity uses. So there's some performance characteristics there that you have to deal with. I can say that Mono's interop performance is not the best. So that's a consideration. .NET Core does compile on a vast number of platforms on 32, so it would definitely not work on a smaller chip. But then there's also size. What is your what memory footprint are you concerned about? And then there's also threading considerations. Python, you have a single thread. Or if you decide to go down something like Mono or .NET, you have multiple threads, but then there are memory trade-offs you're going to have to consider there. Java, feel free to recompile that and deploy that as well. So it sounds very much, and what Lloyd mentioned was about JavaScript. Node.js, have a good time. Just recompile that V8 and shove it over there. And BeagleBones, when they, I don't know if they're still a thing, but when I was playing with those, they came with Node.js, specifically for doing it. And that, the Node.js, the extensibility model, it's right there. It abstracts that platform away. So it really very much depends on what are your constraints, what are your performance requirements, what is your memory footprint allotment. For instance, Mono C, but it compiles much, much smaller. They have a very different design because they're newer and they were designed in a slightly better way than Core CLR, which is a monolithic beast. And so I think Core CLR, the minimum you're going to get is about 65 meg. Maybe you don't have that much space, so Python might be appropriate or Node.js might be appropriate. So it really depends on what you're trying to do and what your performance requirements are.
And I just want to pick up on one thing. So you mentioned at the beginning, I believe you were talking about Android at one point?
Yeah, so this is a part of the question I don't know very much about, but I know there's the traditional sort of pay and play Linux image or like IET core image, but then there's also sort of AOSP and then Android things, which is sort of a different problem if I want to develop C++ libraries for that, because I got to work in the NDKs as far as I know, or do some special stuff there. And that's kind of another tool chain that I have to work with. Yeah.
So if you're in the Android world, and you can stay in the Android world cross-platform, you can pretty much work in Java, and that will cross platform, and you don't have to do anything special there, so long as what you're trying to get at is supported on both platforms. So, Android kind of promotes Java as its top-level user mode or user application language. So that's going to be kind of a natural space if you're big enough and you have Android everywhere you want to be.
So Aaron was mentioning memory issues if you wanted to do something like Mono. Are those just free because Java's there anyway for Android, so you're not taking accounts?
Two sides of that. Yeah, so Java's already there in Android, so you're not taking on any more in Android. But the other piece of say your question again, real quick.
Oh, memory cost.
Because of memory cost.
Yeah.
The other thing on an Android platform is you typically do have a fair amount of memory space. So you're not as constrained just because it's an Android platform. They just tend to build them bigger. And you can... Exactly. And you can run. I've run Java on BeagleBug. You can get it, compile it, run it. Works fine. So it's not that big of a memory hit. I think you really need to get down to kind of like, what are you trying to do and what are the constraints? And then design around that.
But if you're looking for power and performance, you can always interface with the JNI layer to C++ to improve your memory processing, things like that.
Great. Thank you.
Sure. All right, guys. Any more questions?
We got 18 minutes left. We're here.
I'll put the band back on.
We're not here.
I'll start playing the saxophone. Doesn't do it.
So we're working on a C++ library that gets embedded in a C# application, and we're just using load library and invoking methods on the dynamic library. And we just have basically a nice version number. It's this is the ABI version, and if you touch the ABI, change this number, and then we'll throw an error at runtime. Is there any other is there a better way to set that up to actually keep track of your API between your managed and your unmanaged layer, or is it really just hope and pray that the developers change the version number before they deploy the versions?
So, are you calling load library yourself?
Yeah.
You didn't look at DLL import. Doing a load library yourself, having debugged through the load library function, that is a maze that I would not wish on others. It's a very, very complicated loading mechanism, and it doesn't always do what you want it to do. And there are certain things that .NET framework does using DLL import. It would give you a lot of wins. It will discover things for you properly. So that's the first part. The second part of that is the function I'm assuming you're talking about you have a function foo that takes 3 arguments. And maybe foo2 is going to have 4 arguments the next.
Yeah, we basically try to maintain one class or struct in the C++ layer. This is our API, and if you change it, you have to change the number, and then we kind of try to keep things contained.
you say contain, do you mean that if I'm trying to use version 2, that should be okay even though I'm calling version 3? Or should I be told, like, don't be dumb, we're on 3 now, and just terminate?
Yeah, it's to make sure that if you're loading the dynamic library, you know that it actually has all the functions that I'm trying to call. I'm not going to try and invoke a function that doesn't exist and run into
DLL.
Yeah.
That's what you, because what will happen is, for instance, if you load your library, let's call it foo, and it's got a function bar in it, you'll do DLL import, you say, foo is the DLL it comes from, and I'll call it bar. And if you try and call bar in the range code on that DLL import, it will throw a second. It'll say this entry point is not found. You cannot do this. That's the managed exceptions. So you can catch and say, oh, there's no entry point here. Maybe I want to use a different, called key invoke, or fall back and let that exception propagate up. But yeah, I mean, you're touching on like API version design, which is a fascinating subject, and it's a very complicated subject to be clear. So you're not trying something that isn't very, very hard to do correctly. But I think there's a lot of discipline there, and I would, if you're looking for that right out of the gate, this isn't going to work, and you want to fail fast, DLL import using p-invokes or p-invokes using DLL import is really the best mechanism.
Actually, I want to jump up to one other question. We're on a general topic here. Do you know how they're getting mismatched in the first place? So one of the things I've run into across with this is anytime you're generally doing this, most scenarios I've run into, you're deploying the entire system at one time. Therefore, the mismatch is not as likely to happen. Although it does because people don't do that, they do various other things. So I guess, I just want to throw out the possibility of look at your application, look at the way you're using, the way you're deploying the application, and maybe you just solve it by deploying it as a monolithic system, not trying to deploy it as components.
So you don't independently deploy the DLL.
That's right.
Calling code doesn't worry about what version of DLL is.
Exactly. So it's more of a sanity check to make sure things are deployed correctly, rather than I have to adapt to every version. Now, you may have a problem where you do have to adapt to every version. I just wanted to throw that out there as the next higher level avenue you can look at.
Yeah, that's like API design, version are problems. Deployment, build, deployment, and servicing are the problems of our times. And I love the fact that we talk so much about the language here, but there are fundamental, almost close to intractable engineering problems. Just how do I deploy an application that will make sense? And then how do I service it? Those are really hard problems. And if you're servicing it monolithically, that's a win, right? I mean, it's expensive, but it's a win. But if you're trying to piecemeal it, that's a big engineering task. It's not easy to get right. And you won't get it right the first time. You're going to have problems, which may be one of the scenarios.
Yeah. Any way you're asking this question, you're asking.
There's also, use versioning control so that you make sure that what is being pushed out is the links. So if they're not including it in their branch, or they overwrite, make sure somebody says, this is the master branch, this is what is supposed to be there, and if there is your sub-developer, your other developers are accidentally using the previous library version, they can't include them. They can't merge their code until they comply with the main branch.
Thank you.
Sure. All right, one more question. Two more questions. Don't take long.
That's all question.
So I'll preface this by saying I haven't really thought about this problem space before this passed by, actually, as a new requirement came in. So the answer is just do more research. That's very possible. But we have an existing C++ SDK, and suddenly we want to use both in C#. Is there anything we did design KPI for interoperability? Is there anything that we may have already done or that we should should avoid doing in the future that's going to make this very difficult for us.
Are there strings in your API?
Yes.
Thoughts and prayers.
So if you have done C++ for any amount of time, you've hit the string monster, and if you've done it on Windows, you've really tried to slay that list, and you've probably been hurt. I'm hoping that if you have strings and you care about localization at all, you have a unified standard encoding. I can't see your face, so
Sorry,
I'm
what was the
hoping,
question?
I'm hoping that that's okay. That's hard. Those are really hard problems. If you're in Windows and .NET world, we have a myriad of enums and attributes that can indicate that. So I would definitely look at that. I would also say COM is really nice because it gives you a consistent API. It tries very hard to keep that API consistent. But like we all know, padding, struct layouts, those kind of things will really impact negatively your interop experience. So if you have unions, they work on interop and .NET. That's 100% valid scenario. Those are not easy to get right. And interoping strings in particular, that's 3 copies of that string. So if you decide we have a giant JSON configuration for whatever reason, it's 6 meg, 3 times.
One thing I would definitely say is you want to isolate your interop, GUI, your marshalling, your thunking, your translating. Do not let that smear through either your native SDK or your managed SDK, the caller code. Have a thing that's wrapped around. And your managed code is nice and clean and it doesn't know there's anything that's not mismanaged. It hands its system strings in and gets system strings back and goes happily ever after. And your native code is like std string or what have you. The GUI in between is all the yuck in one place and nobody else needs to know about it. That's super important. When you let that leak in either direction, it's so sad.
This is actually a case that is potentially interesting for C++ CLI.
I would write a C++ CLI wrapper around the native.
Especially if you didn't start that way. And as you said, it's like, oh no, we have this new requirement. This is almost identical. This is almost exactly what C++ CLI was designed. We have structs that really aren't designed to be marshaled properly. C++, all right, we want that little bit of wiggle room that allows us to customize these things. And this is where it does actually benefit. If you're starting from the beginning and you can control your struct layouts and you know there's going to be interop marshalling, very often you can write it without C++ CLI. You can make that work because you're thinking ahead and you know how to lay these things out, which requires a bunch of research, but it's possible. But in your case, C++ CLI might actually be beneficial.
So, back from the studying part, study marshalling.
I wanted to jump on something Kate said earlier too. Keeping your marshalling code or your interop code contained on both sides is really, really important. I've had one that came up where we actually had to change the interop partway through. So I don't remember the exact case, but it was like, we had to go Java versus JavaScript or something. You're going in and out of 2 different engines. If you've got them contained, that becomes a much, much simpler problem.
And on a team also, it means that only one person. You say, you gotta go learn about this now. If it's all in one place, only one person needs to know it, everyone else stay out.
Okay, thanks a lot.
Good luck.
Well, you better make sure somebody else knows, or they could have been heading on a bus. All right, next.
Hi, and I actually have a fairly similar question to the previous, just with a different requirement. And we have a C++ code base with a lot of modules, so we're going to pull a fair amount of C++ code into new Android services, which is something that we haven't done before. And so, again, if the answer is just research this whole time, I'm just curious if you happen to have any personal experience in terms of things to avoid, what would make this easy. Are there pitfalls related to the JNI that are beyond the JNI does not support the very latest in what GCC offers, we know that, but are there any just general problems that we should look out for when trying to do this?
Are you touching hardware?
It should be fairly well abstracted out. There's a little bit of the C++ code is doing a fair bit of communication via CAN bus.
So the one we ran into, so CAN bus, sounds like you've got custom hardware involved?
Yes.
Okay. You're probably okay. One we ran into that turned out to be kind of a real nightmare was basically the security and permissions around the J and I interop. And in that case, we were going after camera in particular. And we were right at, I can't remember the version numbers, but we were right at a version number change where Android increased security, the camera was using it, increased the way that was done. That turned out to be a real nightmare for us at one point. But if your primary concern is a CAN bus, that's something Android doesn't really care about because it's not a PII security type device on the system. So they're not paying as much attention to it. So you're probably not going to hit the problem we did.
Okay.
Yeah, I was just trying to create a project with Android, and Android is pretty much allowed users to make easy interfaces with JNI. And it definitely, you just use public native, whatever your function is, and then write your JNI layer with that particular Java encoding, and it's pretty straightforward.
Just remembered as well, the other one we hit was network sockets. We had a similar security problem around that.
Okay, that would definitely become a problem.
Yeah, watch that area. And because of the nature we were doing, of what we were doing, it had to be very high-speed transport, it was a VR type of thing. So we were pushing things a bit, so you may not hit that as well, but those are the two spots we hit problematic.
As far as JNI, it's actually a very good interface. It's verbose, it's incredibly verbose, but it's actually really good. It's something that I'm very jealous of on the .NET side. I will say that we tend to hear a lot about what is the C++ machine, what are the requirements there, what does the spec say? If you're interacting with a VM, whether it's .NET, Python, the JRE, they have their own set of specifications and semantics. And how do they give you a string? Are you responsible for handling that marshal? Those are things that you should also keep in mind. Another thing that is very, very bad, or at least very complicated on Windows or .NET, is threading. It's particularly when COM is involved. It's not like you're on a device, so that probably is interesting. But threading and the memory semantics of the VM and what is the contract between the two are really, really important. And those are just things to really make sure you understand what is your requirement based on what is the job given from the
Okay. Thank you.
Probably the last question, I would say.
I don't really have a question. I think I have a follow-up to this two question-answer pairs. I was a little bit surprised that you guys didn't say something like, oh, follow C-style interface, like it was always the rule if you want to have good API between C and C++. Because it sounded like something, like don't give handles to resources across your API. Don't give something that one version of CRT initialized. Don't let it be finalized by somebody else. It sounds like these are the advices we should give to these guys who write the APIs, such that nothing that one runtime manages suddenly becomes available, but even exceptions. If I understand correctly, in C++, that is being invoked from Java, you probably should avoid any form of exception.
If you're asking about specific, like what are best practices, that's two talks in and of itself. We could really, yes, everything that you said, 100%, and there's more.
Yep.
How do you marshal a number? How do you marshal floating point? How do you handle strings, the encoding? That's a huge disaster. How do you handle exceptions? Are you on Windows as instruction error exceptions? Are they actually C++ exceptions? How does a managed exception propagate into native. What are the semantics there?
Or if it's error codes on one side and exceptions on the other. And I think that's why this idea of isolating your interop code in one place is so important. If it looks, I often say the C++ CLI is a bit like soap. Do you know how soap works? It's a really long molecule, and one end of it looks like oil, and one end of it looks like water. And that's what enables water to dissolve oil out of things. And that's CLI. One end of it looks like C# because it's managed code, and the other end of it looks like C++ because it's C++. And then in between is where all the magic happens, and that's where you do your translation. So if this is an exceptions thing, your GUI layer would be catching them and not rethrowing them because it's not exceptions out the other end, because you're turning an error code or whatever. So the exact mechanics of what guidelines to enforce, it says it's 2 talks, but I will say the way you enforce that is in that interop layer. Ideally a very, very thin layer, but the more mismatch you have between your 2 worlds, the thicker that interop layer gets.
And I want to put on about 20 more berries. Very thin. Very, very thin. The thicker, the more complicated it is, the more behavior, because when those 2 sides meet, there are dragons there. There are very big, ugly dragons.
And I'm going to pile on the case talk earlier. Keep it simple. It should be thin. It should be simple. Because if you, like for instance, I just tried not to manage commercial structures across. Had to do it a couple of times. Not my favorite thing. It's too easy to mess up. Usually you can get away with very simple things. And if you can't, you kind of need to look at, can I refactor this in a way so I can make it simple? It keeps your life so much better.
Well, thank you very much for coming. We hope to do this next year. As not only information for you, but also to show how user groups can grow and interact with the community to spread out information about C++ and the many problems that we are working with. So, thank you for coming.